Hello friends, let's start our next session. In previous session we discussed about qualitative methods and couple of quantitative methods. In quantitative methods we have seen trend projection method and moving average method. Let us look at what is exponential smoothing method. As I said, in exponential smoothing method, we give weightage to the older data points in exponentially decreasing manner. So, this is the equation for exponential smoothing method. This is the forecast for next period for the period let us say t plus 1. This is forecast of previous period, right. Then there is something called smoothing constant alpha, whose value would always be between 0 to 1, and there is something error, right. So, ET is error, right, this is error. So, the error is ST minus FT, whatever is sales in a particular period minus forecast in that particular period, right. So, we will solve the same example which we solved using moving average method, right. So, determine the forecast for 2017 by exponential smoothing method. Given alpha is equal to 0.6. Assume forecast for 2010 as 32, right. So, we have been given, so we collected past data. So, the sales of a particular product in 2010 was 32 and the forecast was also 32, right. So, if you have not been given forecast for the initial period, then you take the forecast is same as demand, right. Had it not been given, had this point not been there in the equation, we would have considered demand, we would have considered forecast in 2010 as 32, right. But since we have been given, we will use that number also in calculating forecast for 2007, right. So, this is the question, let us solve this one. So, you have got different time periods here, demand is there, we also know the forecast for 2010 as 32. So, is there any error? No, there is no error, right. Whatever was the forecast, this was the demand, right. So, error is 0. So, error into alpha is 0, right. So, alpha is 0.6, right. So, error into alpha is there in this equation, right. This error into alpha, right. So, error into alpha for this particular period is 0, right. Next time demand is 36, forecast is 32. So, what is the error? Error is of 4 units, right. So, this 36 minus 32 error, right. So, sales minus demand, right, sales minus forecast, right. So, this term is here, this ST minus FT, right. So, this 36 minus 32, this is 4. So, 4 into alpha, it is 2.4, right. So, error into alpha is 3.36. Now, what would be the forecast for this period 2012? It is the previous period's forecast plus this term, right, which is there in this equation, right. Previous period's forecast plus alpha into error would give you forecast for next period, right. So, this is 32 plus 2.4 is 34.4. How would you get this value? 37.76. This the previous period's forecast plus this value 3.36. So, you will get this forecast. Similarly, this and finally, for 2017 what would be the forecast? It would be 34.46 plus this term, right. So, this is 40.79. So, forecast for 2007 would be 40.79, while the forecast for forecast for 2017 by moving average method was 36.75. So, 36.75 by moving average method and 40.79 by exponential moving average method. Now, which is better? Now, we have to take a decision whether this method is better or previous one was better. We will have to find out. There is something called mean absolute percentage error, right. So, whenever you calculate mean absolute percentage error in these two methods, wherever you get that error less, then that method would be better, right. So, smaller the mean absolute percentage error, better is the method, right. So, let us move on to some other forecasting methods. There are some causal methods, right. As I said, in causal method you have got cause and effect relationship, right. So, we will take up an example. So, a company estimated the potential sales for a new product, a freeze fried instant coffee. Its name is Maxim, right. So, there is a company wants to know what would be the forecast of this particular brand of coffee, right, and following information is given to you, right. So, the total amount of coffee sales is known, 174.5 millions. Proportion of coffee used at home. So, out of this total amount of coffee sales, proportion amount of coffee used is 0.835 million, 0.835. Coffee used at home, you just multiply these two values, you will get coffee used at home, it is 145.7 million units. Proportion of non-decaffeinated coffee used at home is 0.937. So, non-decaffeinated coffee used at home would be very simple, just multiply these two values, right, you will get this value. Proportion of instant coffee 0.40, right. So, instant non-decaffeinated coffee used at home would be multiplication of these two, right, you will get this number, right. Estimated long run market share for Maxim 0.08, and from this value you can find out potential sales of Maxim as 4.37 million units, which is multiplication of these two. So, this is nothing but a series of cause and effect relationship, right. Quite a simple method. You just try this example, very simple example. You know that the population is 130 crore, let us say male population is 51%, proportion of adult 63%, proportion of adults not shaving 10%, proportion of people using premium quality shaving blade 20.5%, number of shaving per year 183, number of shaving per blade 3, and what you want to find out, what is the demand of premium quality shaving blades, right. So, very simple question, you can solve very easily, right. So, let us move on to next method, which is consumption level method. Consumption level method is basically helps you in finding out how the demands would change with the change in income and with the change in price, right. So, the method estimates consumption level on basis of elasticity coefficients, the important ones being income elasticity and price elasticity, right. So, how the demand of a product will change when there is change in price and when there is change in income of a person, right. So, we will take first as income elasticity of demand. So, how the demand will change with respect to income, right. So, this is income elasticity of demand. So, this is income elasticity of demand is you need to have this is Q2 minus Q1 divided by I2 minus I1 multiplied by I1 plus I2 divided by Q2 plus Q1, right. So, Q1 and Q2 are very simple. Q1 means the quantity demanded by you before change in income, and Q2 is quantity demanded by you after change in income. Similarly, I1 and I2 are what? I1 is your initial income and I2 is your new income or changed income, right. So, these are the definitions of these notations, very simple, and this is the question. So, the following information is available on quantity demanded and income level. So, Q1 is 50, Q2 is 55, I1 is 1000 and I2 is 1020. What is the income elasticity of demand? What is the income elasticity of demand? How would you calculate? It is very simple, Q2 minus Q1. So, this is 5, right, 55 minus 55 divided by what? I2 minus I1. So, this is 20, right. So, 5 by 20 multiply by, we just multiply that value by summation of these two divided by summation of these two, right. So, what would be the answer? Did you calculate? Yeah, here is the answer, it is 4.81, right. So, how would you interpret this result? The demand will change by this much unit if there is a change in 1 unit in income, right. Okay. So, this is very simple, income elasticity of demand, responsiveness of demand to variation in income, right. So, what we are saying is if there is 1 unit change in income, there would be 4.81 unit change in demand, right. So, this is the meaning of income elasticity of demand. So, let us look at second consumption level method, it is price elasticity of demand, how responsive the demand is with respect to price, right. So, the formula is this, EP is equal to Q2 minus Q1, it will remain same, it was there in previous method also, P2 minus P1 multiplied by P1 plus P2 divided by Q2 plus Q1, right. So, EP is price elasticity of demand, Q1 is quantity demanded in the base year, quantity demanded in the following year, right. So, this is quantity demanded before price change, quantity demanded after price change, right. P1 is the price of a product initially, right. P2 is your changed price, right. So, this is the question. The following information is available about certain products. So, P1, P2, Q1, Q2, all these values are there. What is the price elasticity of demand? Can you calculate? It is very simple, Q2 minus Q1, right. So, this is minus 1000 divided by summation of divided by P2 minus P1, which is 200, right, and remaining calculations can be done very easily, right. So, what is the answer? Yeah, here it is, right. So, EP is minus 0.37, it means what? How would you interpret this result? Whenever there is 1 unit change in price, the demand will come down by 0.37 unit, right. So, this is price elasticity of demand, right. So, this is one of the causal methods, right. Let us look at another causal method. It is known as end use method. Actually, this particular forecasting method is applicable for finding the demand of intermediate products, and this is also known as consumption coefficient method. So, one and the same thing, either you call it end use method or consumption coefficient method, and there are following steps, right. So, first of all you need to identify what is the possible end product, right. Then define consumption coefficient, then project the output level for the consuming industry and derive the demand for the product. So, these are 4 steps. We will take up an example, things would be clearer, right. So, let us look at this. So, example is we are actually we want to know what is the demand of a particular chemical, right, and the name of the chemical is Inchem. So, this chemical is being used by 4 different industry, right, say alpha, beta, gamma and kappa, right. So, there is one chemical Inchem being used by 4 different industries. The consumption coefficients for these industries, the projected output level of these industries and the projected demand for this particular chemical is shown in this table. So, this is your consumption coefficient. For alpha it is 2, for beta 1.2, kappa 1.8, for gamma 0.5, right. Projected output in X, in the year X, right. So, this is your projected output. So, this is your end unit, right, end product, right, and this is Inchem is your intermediate product. So, what would be the demand of that particular chemical, Inchem chemical? You just multiply the output, the projected output of end product by their consumption coefficients, right. So, this into this you will get this value 20,000, 18,000, 16,000, 15,500 and 69,000, right. So, this is how you can calculate the demand of a particular intermediate product if you know 2 things. What are those 2 things? First is consumption coefficient and the second one is the demand of end product, right. Let us look at leading indicator method. Now, this is a very simple method. So, in this method what we have generally we have got a dependent variable and an independent variable, right. So, we need to find out two variables. So, you can call them either leading indicator and lagging indicator, right, or lagging variable. So, you have got dependent variable and independent variable, right. So, let us take an example. The change in level of urbanization, which is leading indicator, may be used to predict the change in demand of air conditioner, which is lagging variable, right. So, this is your independent variable and this is your dependent variable, right. So, whenever there is urbanization taking place, there would be demand of some other products which would be increasing, right. So, when you have more urbanization, what you will have? You will have, let us say you need more transportation facility, you need more jobs, you need more schools, you need more hospitals, right. So, just your level of urbanization is just one independent variable, and through this you can find out what would be the values of dependent variables, namely number of hospitals, schools and so on, right. So, this is very simple method. Another example can be temperature. If you got more and more temperature, you would have more and more demand of air conditioners, fans, there would be more power failures during summers, then you would be requiring more and more inverters, right. So, the important point in this method is you need to find out leading indicator and lagging indicators, right. So, this is what I have already talked about. Identify your leading indicator, establish relationship, right, between leading and lagging indicators, right. The advantage of this method is that it does not require a forecast for an explanatory variable. What is explanatory variable? Explanatory variable is similar to independent variable, right. So, you need not forecast independent variable, right. So, its limitations are that it may be difficult to find appropriate leading indicator and lead lag relationship. Many times what happens, lead lag relationship is again an important point. Let us say if there is a price hike of fuel, due to price hike in fuel you will have inflation, right. So, one is leading and one is lagging, right. But you need to find out after how much period price hike of fuel has affected inflation, right. So, that point is also to be taken care of. It is called time lagging, right. So, this is leading indicator method. Let us look at econometric models or econometric methods. So, this is somewhat similar to what we have seen in previous slide. So, what we do here, it is a mathematical representation of economic relationship derived from economic theory, right. So, we forecast the future behavior of economic variables which we incorporate in our mathematical model. So, you can have either a single equation model or simultaneous equation model. So, if you look at single equation model, so this is a very simple model. So, you will have one variable. So, the dependent variable also known as explained variable and independent variable also known as explanatory variable, right. So, explained variable and explanatory variable, right. Explained means dependent and explanatory means independent variable, right. So, an example here is, let us say demand for a certain product in year T is a function of two independent variables, namely price of the product in that year and income in that particular year. So, A0 is nothing but a constant, right. This is nothing but your multiple regression equation, right. So, there is one dependent variable and these are two independent variables, right. So, and A1 and A2 are coefficients, right, A0 is constant, right. So, this is a single equation econometric model, right. Then you have got simultaneous equation model. So, instead of one equation you have got two equations, three equations and so on, right. You can have different series of equations, right. So, let us say consider a highly simplified three equation econometric model, right. So, let us say GNP, gross national product, is being determined by, let us say gross investment, right, consumption, this value, and government purchases, right, this value, right. So, you have got CT here, consumption, GT, government purchases, and IT is investment, right. Again you can find out gross investment is function of this, then CT, consumption, is a function of this, right. So, you can have three different equations, right. So, this is simultaneous equation model. Now, let us look at next method, it is called strategic advantage method. In this method what we do, we forecast the demand of a product depending upon what is the price of a product in Indian market and what is the price in international market. So, for example, let us say if the price in domestic market is less than price in international market. So, you will have more and more export opportunities. So, this is basically an indicator that when there is a price, when there is higher price in international market, sell your products there, right. So, you can forecast in this way, right. So, if you are able to forecast the prices in international market and in domestic market, you can plan your forecasting accordingly, right. In exactly opposite case, if you have got domestic prices are higher than international prices, then it is good to import products from abroad, right. So, this is nothing but a simple strategic advantage approach, right. Now, whenever we go for forecasting, you will always have some errors, right. So, this is an important point. There are lots of uncertainties in forecasting. So, why there are so many errors in forecasting? Most of the times forecast errors will be there, whether it is small or large, right, but errors will be there. Why? There are a couple of reasons for that, and the reasons are, many times you do not have exact data. Forget about exact data, you do not have data sometimes, right. So, even when you have data, they are not standardized data, right. There would be some missing data, sometimes 20% missing data, sometimes 30% missing data, and so on, right. So, data about past and present markets. So, there is a lack of standardization and so on, right. Many times we do not use appropriate method to forecast, right. And the other problem is there are several qualitative factors which we cannot, which we convert them into quantitative variables, but sometimes it is difficult, right. And this is the most important problem in forecasting, unrealistic assumptions. We make lots of unrealistic assumptions, and we are fascinated by optimistic assumptions. We think that everything will be all right, there will not be any problem in future, right. So, we take some unrealistic assumptions, and because of that our forecasting models most of the times go wrong, right. And environmental change, of course, affects our forecast. So, there is a change in technology, if there is a change in government policy, right now we will have a GST into picture very soon, from most probably from 1st of July, things will change, right. So, whatever people have forecasted demand of their products, they will have to revise it, right. So, this is nothing but environmental change, right. I will give you an example. Let us say development of international scene. Let us say if Organization of Petroleum Export Companies, OPEC, decide to cut down oil production, then what will happen? Prices will shoot up, right. So, this is nothing but environmental change, right. And of course, discovery of sources of raw material. If you are coming up with new material, or let us say government policy has affected the supply of raw material, then things will change and so on, right. Quality of monsoon in India, right, very important point. If it's going to be a quality rain, then everything would be all right, otherwise you will have to revise your estimates, right. So, the last point in market and demand analysis is market planning. So, in market planning, generally what we do, we go for current marketing situation. So, after doing all those things, right, situational analysis, secondary data, primary data, market characterization, demand forecasting, we go for market planning, right. So, you have got opportunity and issue analysis, objectives, marketing strategy, and action programming. So, with this we complete this particular session, and this particular topics also, right, which is on market and demand analysis. Thank you for watching this session.